So we've got some vocabulary to do. A central angle means the vertex of the angle is on the center of the circle. So it would be something like the angle APB. An arc is a piece of the outside of a circle. So we could have something like from A to B. That would be arc AB. A minor arc is an arc that is less than 180 degrees, so less than halfway. So arc AB is a minor arc, goes less than halfway around. Arc BC would also be a minor arc, that's less than halfway. The key thing about minor arcs are they are named with 2 letters typically. A major arc is an arc that's more than 180 degrees. So it would be something like arc A, B, C. Or it could be arc C, A, B. And major arcs must be named with 3 letters. Because if we just said AC, then that would be going straight from A to C. When we say arc ABC, we know we have to go from A to B to C. A semicircle is an arc that is exactly 180 degrees. So let's say we have a diameter through the middle. I'm going to make this point D. Arc AD would be a semicircle. It goes halfway. It's 180 degrees. All the arcs in a circle will always add up to 360 degrees. So for arc addition postulate, say we wanted to know the measure of arc ABC. But we don't know what that is. But if we know AB and we know BC, then those 2 arcs added together would give us the length of the whole arc. So let's look at some examples. Given that AB is a diameter of circle P, AD is congruent to BE. So I'm going to start by marking that on my picture. Arc AD is congruent to arc BE. Arc BF is congruent to arc DE. So BF and DE. The measure of arc DE equals 80 degrees. So now we're going to find out all these. But first, I want to label the picture. So we know that AB is a diameter. So from A to B is 180 degrees. If this part's 80, then that leaves us with 100 degrees for AD and BE. Well, we know they're the same, so I'm going to divide by 2, and now I know that those are each 50 degrees. Since DE and BF are congruent, I know that this piece is 80 degrees, And since A to B is a semicircle, if this piece is 80 degrees, then AF has to be 100 degrees. Now, one thing I'm going to point out here, even though the question doesn't ask us for it, is these angles inside, the central angles, or the measure of your central angles, is congruent, or is equal the measure of the arc. So if BE is 50 degrees, then angle BPE is also 50 degrees. If arc AF is 100 degrees, then angle APF is also 100 degrees. All right, now let's go back to our arcs. We're going to determine if it's major, minor, or a semicircle, and then we're going to find the measure. So BE, that's less than halfway, so it's a minor arc. It's also named with only 2 letters. And we said it's 50 degrees. FA, we said is 100 degrees. It's also a minor arc. AE, that's less than halfway, so it's a minor arc. A to E, well, we don't know that whole thing, but we know A to D and D to E. So 50 plus 80 means that it's 130 degrees. DFB. Now technically you can name a minor arc with 3 letters, so let's double check that this is a major arc. From D to F to B. Yep, that's definitely more than halfway. So from D to F to B, which has these 3 pieces in here. So 50 plus 100 plus 80 means that that arc is 230 degrees. From B to A to E. It's definitely more than halfway, so it's a major arc. Now, from B to A to E, we could add up all these pieces all the way around, but it's everything except this piece here. So a shorter way would say the whole circle is 360. Let's subtract 50 degrees, which means BAE is 310 degrees. Arc ADB, A to D to B. Well, that's exactly halfway, so it's a semicircle, which we know is automatically 180 degrees. Then FDB, definitely a major arc, and it's everything but this slice here, so 360 minus 80 means that's 280 degrees. To our pieces of circles. So important things about circles. We have the circumference of a circle, which is just a fancy word for the perimeter of the circle. So that would go, let me use my highlighter. That would go all the way around the circle. The formula for this is on your formula sheet. It's right here. You can find circumference using radius or diameter. Typically, we're given the radius. So the circumference equals 2 pi r. And our units are one-dimensional, so it would just be centimeters, inches, feet, etc. An arc length is a portion of the circumference. So let's say here's our center. We have point A and point B. We might want to know how long the arc is from A to B. Now we previously found the arc measures based on the angles, but we're saying this is a bigger circle, it's going to have a bigger arc length. If it's a smaller circle, it's going to have a smaller arc length. So we want to know just from A to B how long it is in meters, inches, centimeters, etc. We calculate this by taking the circumference and multiplying it by the number of degrees of that angle or arc divided by 360 degrees. So we're going to have to use our circumference formula. A sector basically looks like a pizza slice or a pie slice. And it's asking us how much area, how much space of the circle is taken up by this. So for this, we would multiply the area of the circle times the degrees over 360 degrees. The formula for the area of a circle, again, is on your formula sheet right here, and it's pi r squared. So let's look at some examples. Find the area of the sector that is shaded. So we're going to have to use our sector formula. It's the area, which they didn't give us, so that we're going to have to use pi r squared times the degrees over 360. So bring down the pi. Our radius shown in the picture is 3. Divided by the degrees of the angle and the arc would be 70 degrees over 360 degrees. So let's put that in our calculator. Pi times 3 squared times 70 over 360. And we get that that sector is that would round up to 5.5 feet. And because it's an area, the feet will be squared. The area of the following shaded sector is 49.1. So they're giving us the answer this time. We're going to have to work backwards. Find the area of the circle. So we know that 49.1 is equal to the area times the degrees over 360. Now it gave us the area of the shaded sector, so we need to know the degrees for the shaded sector. Remember, the whole circle is 360 degrees minus the 135 that we were given for the non-shaded area. And that leaves us with 225 degrees. So that's the degree we're going to use here. To get A by itself, you can either divide by 225 over 360 on both sides, or you could have multiplied by the reciprocal. But if we do 49.1 divided by 225 over 360, we get 78.56 centimeters squared is the whole area of the whole circle. Since the shaded part was 49.1, we know that this final answer should be bigger than 49.1. Let's do some arc length problems. So find the arc length of AB. Our formula we said was the circumference, so 2 pi r times the degrees over 360. So 2 pi, our radius is 6, and our degrees for this arc is 135 degrees. Put it in our calculator. 2 pi times 6 times 135 over 360. And then we get the arc is 14.14, and we're measuring in feet. Find the circumference of the circle D. So again, we're going to have to work backwards. We're given the final answer, so 4.19 equals the circumference times 40 out of 360 degrees. So we're going to divide both sides by 40 over 360. .19 divided by 40 over 360, and we get that the circumference was 37.71 inches. That's all for today. I'll see you in class.